All right, welcome back to the last two sections of chapter 4. And notice, even though we did 4.1 and 4.2, which was all sines and cosines, not just their parent functions, but also their translations, moving them, shifting them, stretching, reflecting, all of that yoga-ism. We're going to move on to 4.3 and 4.4, but I don't like the order that the book goes in, so I'm going to do 4.4 before 4.3. Okay, so we're going to do secant and cosecant before we do tangent and cotangent, right? And you'll see why hopefully in a minute, because we know what cosecant is. Cosecant of any angle is the r over the y, which is just the reciprocal of sine. So since I know that that is equivalent to 1 over sine, then what I'm going to start by doing in order to graph cosecant, rather than doing a big old nasty t-chart and going through and plugging in a bunch of these inputs here and seeing what we got out to get a bunch of ordered pairs, x and y's, and plotting them, I'm just going to graph sine. And the reason I'm going to graph sine is because I know that this is just the reciprocal of it. So we know that this is equivalent. And we know that sine is equal to 1 over cosecant. They're reciprocals of one another. So what we're going to start by doing is just plotting those quadrantal angles, which we already know is 1, 0, 0, 1, negative 1, 0, 0, negative 1, and then to get all the way back and close that circle off, we got 1, 2, 3, 4, 5 key points. Okay, these two share the same spot to get our closure. Now remember, we also know, since this is the unit circle, that our radius is 1. The cool thing is we therefore know sine is always equal to the y over r. And since we're on the unit circle, our sine would only be focused on the y value. So whether I go 90, 180, 270, 360, or pi over 2, pi, 3 pi over 2, 2 pi, either positively around or negatively around, we know that we cut it into our 4 quadrants. So we're going to list and label our 4 quadrantal angles there in both directions. We're going to label to make sure that we know that these are going by 90 or pi over 2 radians. 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Again, in both directions. And remember that the highest values that we will ever get out for our y values, again, only focusing on the y's because of sine, starts at 0 when we're going 0 degrees or radians. So I'm going to list this sine very lightly in this green color, lime green color. So I know at 0 radians or degrees, I get 0. That's what my y value is. Then you can see it would increase, increase, increase all the way until we got to 1 at the next quadrantal angle. Then it would slowly decrease and get back to 0. And then it would increase, but in the negative fashion, to become a negative 1. And then still negative because it's below the x-axis, right? Positives versus negatives. Sines positive, sines negative, until we got back to our 0. And we know it would do the same thing, but in reverse the other way. So negative 1, 0, 1, and 0, and everything in between. There's one period of time that it takes to then repeat itself all the way around. Now, so what? Why am I reviewing sine? That's what we did last week for 2 full sections. What we're trying to graph is what? The reciprocal function to sine, which is cosecant. And if you remember or recall that all of these values were 0/1 for sine, what happens when we take our sine values, which is our y/r's, and we do the cosecant of those same inputs, those same angles? Well, we know we get the reciprocal, hence the name, reciprocal functions. We get r/y, which means these will flip, and I will get 1/0. And guys, what do we say we get whenever we're trying to divide by 0?
Undefined.
Very good, guys. Undefined. How on earth are we going to graph an undefined value? What does that look like? How can we show them that for a 0, a pi, a 2 pi, or negative pi or 2 pi, when we put that in for our angle for cosecant, what do we get out? Are we positive? Are we negative? Are we a half, a 1? What do we get? Well, 2 of you just said that it's undefined, which means we're not up or down any. So what does that mean that we're going to have to draw to let you know, hey, for this input value, you don't get anything out? Have you guys heard of an asymptote before? An asymptote is basically a borderline. It's something that our graph will approach very closely, but never actually reach, because what we said when we plug this in, we don't get anything out. So what we are going to do is draw everywhere there was a 0, because we know when we flip that 0 that it becomes undefined. And this is how graphically we show you that there is no value that will come out when you input certain things, namely any pi, positive, negative, or even no pi's. So our graph is looking much different already than our sine wave. Notice we got these dashed vertical lines. Well, then obviously we need to figure out what goes on in between. Well, we talked about what happens when we flip a 0. We get undefined. Well, what happens when we flip a 1 or a -1? Well, when you take a 1 and you flip it, you get out a 1. And what if it were negative? Well, when you flip that, it's still going to be a -1. So the zeros resulted in these vertical asymptotes every pi, but the ones and negative ones will end up staying the same value. So that, all of those points will still be there just like they were for sine. But what about all these other values? What about the sine of 30? What do we say the sine of 30 degrees or pi/6 is equivalent to? Well, that's one that we should all know. It's the easiest to remember. It's not the root 2 over 2 or the root 3 over 2. It's just 1/2. So when I go over here to my 30, my 45, my 60, in quadrant 1, 2, 3, or 4, I should know those heights, those y values, those outputs. And I know whether they're positive for sine or negative for sine. But we're talking about cosecant. And if I'm still evaluating that sine of 30 or pi over 6, then what if I rewrote it as cosecant? What would that yield? Again, just the reciprocal. So now instead of being over 30 degrees, up 1/2, now it's going to flip all the way up to 2. So you see, when we have really small measurements, like 1/10, 1/100th, 1,000th, what happens when we flip it? That really small value is going to get really big. So the cool thing is, it's really quite simple. If you can kind of see this little piece of what looks like a parabola of our sine wave here, and then here, that are now broken up by these asymptotes. Well, remember, these are just reciprocal functions, which meant to just flip them. Well, then that's exactly what we're going to do to this and this. We're going to keep that 1 over 1, that negative 1 over 1, and we're going to flip them. Because we know those values that were really, really small over here, in here, when we flip, get really, really big. So the best thing for me to have done would, instead of drawing it lightly, would have been to dash. So that you can see, you know what? This was the original sine wave through 2 periods, because it's repeating itself twice. But that's not actually part of my graph. What is the graph of cosecant? It is this and this with these broken up vertical lines we call asymptotes. That, my friends, is the graph of cosecant. Now, of course, we can do that in either direction, and you can see that we would not only have it once, but twice, which means, what is the period for cosecant? Well, hopefully you can see from 0, it would take 2 pi in that direction or that direction to get the exact same graph. So the cool news is the period is still 2 pi, which means our quarters, if we took that 2 pi and cut it into fourths, we know that that would cancel and still give us our pi over 2 increments in either direction again. Now, what about the amplitude? Well, remember, the amplitude was how high up and down our sine went from 0, or the x-axis. And we knew that it went a height, a maximum height of 1 and a minimum height of 1. In the downwards direction, we just call it -1, +1 in the upwards. So for sine, there was a highest and lowest point. So we said the distance we went from 0 was both 1, up and down. Well, what about the amplitude for cosecant? Is there a highest and lowest point? Absolutely not. That's why it's important to draw these asymptotes, these borderlines, because this arrow shows that it shoots up and or down to infinity. So there is technically, I'm going to say technically, not an amplitude for these, but I'm still going to use the fact that A is 1 to refer to the amplitude, even though there technically isn't any. Because what can we do to make this move up or down? Stretching it or compressing it, I could throw a 1/2 in front. And since it's not being done to the x, it's going to affect my y. And remember, y's are y's, we do what they say. So if it says 1/2 in front, I will make my y values half as big. So this would move to here, and this would move to there. Or if I wanted to make it 3 times as big, then I would go up to 3 and down to 3. So we're going to still use that amplitude, even though there isn't any for cosecant. All right, and we'll talk about the other things, the shifting horizontally, we call phase shift, or vertically up and down, that vertical shift as well. We could even have a reflection, and remember, a reflection, we just throw a negative to make it all the opposite. So now my 1 and -1 would flip-flop, which means now it would be facing down, and this would be facing up. This one would be facing down first, and then this one would be facing up second. Okay, little things like that that we kind of practice with sine and cosine because they are the best and easiest of all the functions. So what I'm going to ask you to all do right now is the next one. On your own, using the same basis that I just explained to you for cosecant. And hopefully you can know how are you going to start this one? By graphing what first? Cosine. All right, give you a few minutes, give that a shot, and then we'll come back and make sure we go over it in detail. All right, let's see how you guys did. Again, starting with cosine. Remember, the unit circle is what we're going to refer to. And on that unit circle, we know the 4 quadrantal angles, their values. And all you need to recognize is the fact that cosine, and I'll use the correct color there, but cosine of any angle is always equal to the x over r. If they don't specify, then we get to choose the size of the circle, and we're always going to choose the easiest one, and that's a radius of 1. So that means that this becomes a 1, and therefore we're just focusing on the x values now. But again, notice that if we start in this direction at 0 degrees or radians, my x actually starts at 1 this time. Then the x gets smaller and smaller and smaller as we rotate all the way until 0. Then the x is going to get a little bit longer and longer in the negative direction until we get to a -1. And then back to 0 and all the way around back to 1. In both directions, again, we could go negatively, then it would start at our 1 and go to 0, -1, 0, and 1. Either way, we yield this graph. There's 1. And there's the second repetition or period of time that it takes to get there. Now, of course, just like before when we did the sine wave up above, we looked at all of the zeros first, starting on our x-axis, and we knew when we flipped a 0, it became what? When we flipped a 0, it became undefined. And we said graphically, when there's that 0 on bottom, and therefore is undefined for these inputs or angles, which notice for these, it's every 1, 3, -1, -3, or if we kept going out here or out here, 5 or -5 pi/2s, it's every odd pi/2 that we have an issue. And how we graph those issues, those undefined, no output values, is we show you there is no value for that, or that angle. Now we also said if we took the 1/1 and we flipped those, or the -1/1, we would get that same thing out, a positive or -1, which means all those values again will stay as a -1 or +1. And the same thing went for those fractional parts, those really small values. For this angle, 85 degrees, we get something real small. Well, when we take something very small like 1/10 and we flip it, it becomes very, very large. And we can get so close, like 89.9 degrees, that we're going to just say it goes to infinity. So take all of those half parabola looking pieces and do the reciprocal, flip them. Approaching those asymptotes, but never touching. Remember, those are our border lines. Now, again, hopefully you can see the time that it takes to repeat, because I could technically take this one or this one and flip just its half. And if I just looked at half of my graph from 0 to 2 pi, you can see that I'd have the right side and the left side to finish that off if I move this over there with my whole parabola looking shape down here. So the good news is it's not as easy to see, but you can see that hopefully from 0 to 2 pi, we have an entire period. So again, period, 2 pi, quarters, pi/2, all the same as sine and cosine, which is why I did this section before we get to the last two, tangent and cotangent. Okay, now the amplitude, again, because it shoots up and down without bound, it goes to positive and negative infinity. There is technically no amplitude. Okay, but I'm still going to use that A value to let you know about any stretching or compressing vertically. All right, so we'll still use this, we'll still call it the amplitude and refer to it because that's where we know our sine and cosine amplitude changes are. So if we double it, now we're going to be up at 2 and -2. And we'll still draw it similarly. Okay, that's it for that section. I wanted to give you everything for your notes in a nutshell. If you wanted to take a screenshot of this or pause it and write down all the key things, again, you can see the graphs here and here without having to do all of that. You can see our domain is almost everything, with the exception of the any pi's or the odd pi/2s. depending on if it's the cosine or the sine function. And then the range is quite weird because remember with sine and cosine, the range oscillated from -1 to +1, everything in between it. Well, now when we flip that and do the reciprocal, now there's this void in between. There's this void in between -1 and 1. So now it's everything down here all the way up to -1, including it. And then we need to unite the other half, which starts at 1. So including it and going up to infinity. Remember, never including infinities, whether it's positive or negative, because you can't physically touch or plug those in. Okay? So you can see there's no intercepts. Period is still 2 pi for each of these. And because there's no max or min, there is no amplitude technically, even though we'll still refer to it for any translations, stretching or compressing. And then remember we mentioned the symmetry stuff. Okay, don't worry too much about that, but again, it's there for your convenience. All right, so we're going to move on to the last two. The last two trig functions, which is technically 4.3. Again, I just don't like the order of the book, so I'm rearranging it. And that is tangent and its reciprocal function, cotangent. Okay, so I'll start by graphing tangent with you and then do the same thing, ask you to do the reciprocal function, cotangent. And where do you think we're going to start? Well, we know tangent is always the y over the x. So it's not as easy as sine and cosine, which is why we started with those and left this for last. It doesn't have that r on the bottom where we can just focus on the top. For sine, that was y. For cosine, that was x. Now, for tangent, we have issues whenever x is 0. We know that that can't happen. That gives us those vertical asymptotes, those undefined places. And because we're going to go back to our unit circle, and we're going to plot those points that we already know, both x, y, and even r, even though we don't need it for tangent now. We should therefore be able to plot all of these angles outputs. Again, starting at 0, going to pi over 2, pi, 3 pi over 2, and then all the way around to 2 pi. So I will graph those. Again, in both directions. Remember, you do not have to draw this to scale, but it does need to be labeled properly to make sense for anybody that was looking, or for me to award you full credit so that I know what you're doing completely. So let's start by starting at 0 and seeing what the y over the x would be. Again, if you want to do the t-chart for the inputs and outputs, that's fine too. Just remember this x and y are not the same as this x and y. A little confusing there. All right. So my input is going to be my angle of 0. Start there. And then I know at 0, I get the y over the x always, which would be 0 over 1. Perfect. I know I'm starting at a 0. Let me use a better color. All right, now that I have that, I'll keep graphing. Let's go to the next one, pi over 2, or 90 degrees. I know it's still the y over the x, but notice that's where one of my issues lies. So I'll go ahead and highlight that. And you can see there are 2 places on my unit circle where the x is going to be 0, and 2 places where the y is going to be 0. And as long as the other thing isn't a 0 that we're dividing by, it's all good. So this is going to be a 0 over 1. It's going to be a 0 over -1. This one would be a 1 over 0 and a negative 1 over 0. And remember, we're actually technically doing this twice at our starting and ending point. So there's my 5 values. They're all zeros or undefined. And that's nice because I know that this is going to be a 1 over 0, which means vertical asymptote. This would be a 0 over negative 1, which is 0. Then this is going to be a negative 1 over 0, again undefined. And back around would be 0 over 1 again for my y over my x. Now what if I went in the opposite direction or negative direction? Well, going down to negative pi over 2 would yield my undefined, and you can see the pattern. It went 0, undefined, 0, undefined, 0. So we're going to do the same thing in the opposite direction. 0, undefined, 0, undefined, 0. So the zeros will be at all of the pi's. 0 pi, 1 pi, 2 pi, negative 1, negative 2. And the vertical asymptotes, the undefined outputs, are at every odd pi over 2. But unfortunately, is that enough to graph? Do you guys know what the graph looks like based off of just my quadrantal angles?
No.
Unfortunately not. So Luis and everyone, we got to pick another angle. And we got to pick an angle that's not on our quadrant because we've exhausted all of those 5 points. So what is your favorite one for tangent? Which angle?
45.
Yeah, very good. Why did you choose 45, which is right in the middle of all these?
Because it's equal to 1.
Very good. We know the tangent of pi over 4 or 45 degrees is equal to 1. It just depends on which one we're looking at. And what do I mean by that? Depends if it's in which quadrant. And we know that it's positive in these quadrants and negative in the other. So when I split the middle, I get the 45 for each one of my 4 quadrants. Remember, all students take calculus. Is that acronym that we use to know whether each thing is positive or negative. And notice I put the positive for tangent up here, the negative down here, because that's what we're referring to. The positive versus the negative from our 0, our x-axis. So since we know that 45 is a 1 or a negative 1, notice again, it just alternates from a 1 to a negative 1, a 1 to a negative 1. And is that enough to now graph? Well, it kind of looks like these could just be a straight line, doesn't it? But we know that can't happen because can we cross through the asymptote?
No.
No, remember those were the values that didn't come out. We didn't get anything for that. So we can't say that there is one right here and right here to draw this line. So if it's not a line, that means it has to have some what to it.
Curvature.
Very good, Charles. That's the perfect word, curvature. And remember, we could do the 30, we could do the 60, or use our calculator to get any value. We should know the tangent of 30. What's the tangent of 30?
Half.
Careful. That's for sine.
Oh, whoops.
Okay. The 30, 60, 90 for tangent is √3 over 3. And the tangent of 60, which is pi over 3, is just the √3. So yeah, we could get these values, but what is root 3 and what is root 3 over 3? I'd have to punch it in my calculator, so it doesn't really help. All I know is that this asymptote and this asymptote means that this is going to have to shoot down and get really close to it, and shoot up and get really close to it. So that's enough. At least it should be, in order to graph tangent. Now again, notice if I did this one, I'd only have the left half of it. I could do the other half if I kept going with my graph, which we definitely could. But I also did the negative, so let's do that. Remember, cosine in quadrant 4 is the only thing positive, so we're going to have that alternating from +1 to -1, +1 to -1, +1 for each 45-degree reference angle in each one of those quadrants. So I'm going to have my -1, +1, -1, +1. And hopefully now you can see more of my tangent. Now, guys, let's talk about some of the things that we've been talking about, like the period. And once we know that, we can get the quarters. The amplitude. Which one of those do you want to be able to tell me right now?
Would the period be 2 pi?
It's a good guess. Everything's been that, right? For sine, cosine, and its two reciprocal functions, cosecant and secant, respectively. But does it look like it takes an entire 2 pi to repeat itself?
No.
Yeah, very good. No, it doesn't. Because with sine, look at my sines. It was positive, then it went negative and negative. And then it would start repeating positive, positive, negative, negative. So it took a full circle, because we know all the values are going to be the same. It's just the signs that are going to change. Let's look at cosine. It was positive, negative, but then negative, positive. So it didn't repeat until we would have gone all the way around. Positive, negative, negative, positive, positive, negative, negative, positive. But what about for tangent? Again, all the values in every quadrant are all going to be the same triangles. You can see that here. But what about the signs then? What is it for tangent? Positive, negative, positive, negative, positive, negative, positive, negative. Did we have to go a full circle for the signs and therefore all of the angle measurements to repeat?
No.
It actually took how much time, Luis?
3/4 of a circle?
Close. It only took half,
Oh,
right? It went from positive to negative, and then what?
back to positive.
And then back to negative. So it only took half the circle to repeat itself. And notice, Luis, do you see each and every one of these? Those
Yeah.
are a repeat, right?
Uh-huh.
Well, then how far is that distance from 0 to what? Pi over 2. What is it for this distance from 0 to what?
Pi over 2.
Just in the negative direction. And if you take 1 pi over 2 here and 1 pi over 2 here, what do you get?
Pi.
2 pi over 2's, which very good, is pi. Which remember we said a full circle is that, it only takes half the time to get there. Pi. radians or 180 degrees. So unfortunately, they all don't behave the same way. At least 4 out of our 6 do. Well, we haven't looked at the last one yet, right? But you can assume that if tangent behaves this way, cotangent is also going to behave the same, because remember, it follows the same pattern for positivity and negativity for the values. So yes, unfortunately, this is the one weird thing for tangent. It takes half the amount of time to get there, which means what therefore are our quarters going to be? Well, what were they for all the other ones? Pi over 2, because we just took our 2 pi and cut it into fourths, and that gave us the pi over 2. But what happens when we take this and cut it into fourths? Ah, Luis, remember you said that this was going to be a pi over 4?
Yes.
To get our good values out? Well, then look, we still have our 1, 2, 3, 4, 5 key points.
Wow.
Little different, same idea. But again, just going off of the unit circle, we can get most everything. We just had to add in a little bit more to get the actual shape of our graph for tangent. So what about the amplitude? What do these arrows mean?
That they keep going.
Going.
Which means, very good, guys. Again, technically, I'm putting air quotes around that, right? Or real quotes. There are none. There is no highest or lowest point anywhere on this graph. It shoots up and down to the infinities. Forever. But I'm still going to use the fact that this can be stretched or compressed. And what value did we use as our starter? What do we always compare to? R1, which that's one of those quarters that we already dealt with. Okay, so that's the one that we're going to use to stretch or compress, either down to compress or stretch out, up and down. Okay, that's pretty much it for tangent. Of course, we will do some of those things. I can throw a negative in front of tangent, which, since it's not being done to the x, it's going to affect the y. So all these positive y's would flip down. All these negative y's would flip up to become the opposite. Now, guys, I'm going to throw a little joke at you to hopefully help you remember this tangent and cotangent stuff a little bit later. All right, so I'll come back and refer to this. But remember, if they only ask for one period, you don't need any of this or any of this. You can just go pi over 2 both directions, cut that in half, do your 1 and -1, draw it along with your asymptotes, and that's one period. Okay, and as long as you have everything labeled, that's good enough for me. If you can do it once, I know you can repeat it to the right or the left. So do me a favor. See if you can now do cotangent on your own. Okay, go ahead and pause it here if you're watching this back. You guys go ahead and try this one now for those of you that are here and working live. All right, guys, hopefully you were able to come up with something along these lines, but let's quickly go over it. Remember, cotangent is just the reciprocal of tangent. So since we had y over x for tangent, we're now going to have x over y. Now you can build the unit circle and do the exact same things the exact same ways, noticing that you cannot have a 0 for y. And when that would happen is along our x-axis now, right? Whenever we were dealing with 0 or pi or 2 pi or 3 pi or 4 pi, however many times you want to go around in either direction. Or because we just graphed tangent, you know that at everywhere we had a 0, which for us was the 0 over 1 or -1, when we flip or do the reciprocal of that, that will now yield those issues, which now that means our asymptotes will be at those pi's. Okay, so when building this one, we're going to have at 0, pi, 2 pi, or in the other direction, -pi, -2 pi. That's now where we will have the issues. And of course, for the other variation, x over y, we would have 0 over 1 instead of the 1 over 0 or -1 over 0 issues. Zeros on top, okay. Zeros on bottom, can't do. So that means I now classify where my zeros are. And of course, that would be right smack dab in the middle of those uprights for all you football fans out there. Kicking that field goal right down the middle. But again, just like before, that's not enough for us to graph. So we will select those 45-degree angles that are both positive and those 45-degree angles that yield a 1 where it's negative. So as you can see, all students take calculus will give me those 1s for my 45 degrees, which are the middle halfway point between my 90s. So a +1 here, -1 there. +1 here, -1 there. Again, alternating. 0. Radians or degrees gave me an asymptote. Then it was a 0, then an asymptote, then a 0, then an asymptote. Then we went from 1 to -1, 1 to -1. And again, we can do the same going in the opposite direction. That would be our -1, +1, -1, +1. And now hopefully you can see, just like before, it's not going to be a straight line because we don't have those values coming out for our range, but we do have this downwards facing. Decreasing function we call cotangent. And just like before, we want to talk about the period, quarters, and amplitude. And hopefully you can guess that it's the exact same. You can see this one even easier, starting at 0 and going to pi. That's the time that it takes to repeat itself. And if we split that into fourths, you can see we'd have our 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4, starting at 0. There's our 1, 2, 3, 4, 5 key points yet again. Okay, still technically no amplitude, no max or min, but we will still use that 45-degree reference angle of 1 to stretch or compress. All right, so here's a little joke to help you remember both tangent and cotangent. If you want to get a tan, you look up to the sky. And don't forget to tan both sides of you. So both sides of 0, the positive and the negative. But for cotangent, that starts at 0 for cotangent. It's got the O in it with our asymptotes. And you always hang your coat going downwards like that. All right, so hopefully those little monikers will help you to remember what it is for the looks of these things. And I will let you know to classify which is which. It's all about the asymptotes. Okay, because as I mentioned to you, I could flip this to be the opposite direction by just throwing a negative in front. And that would now make it look like this. What you're thinking, oh, I'm hanging my coat. It's a coat. No, because it goes through the 0, the origin, where this one does not. It's an asymptote there. So just because it's decreasing or just because it's increasing doesn't necessarily mean it's immediately cotangent or tangent. It's all about where the asymptote is. And unless anything is shifted, for example, left pi over 2, then yes, if I shifted this left pi over 2 to my x, then it could still be a tangent graph going upwards. Just shifted everything left pi over 2. All right, so keep that in mind as you go through these. Here's everything together to make sure that you have it all in your notes if you want it. Again, talking about the domain, what things we can put in, really where we're looking at what we can't. The range for these is everything. There is no void, like there was that gap in between secant and cosecant. What can't work, what can come out, right? We do have x-intercepts for these, and the period, again, that is the most notable thing that you want to make sure that you have in your notes. Is that it only takes half the time. Everything else, the period is 2 pi, other than tangent and cotangent. Okay, so just to let you know, there will be some of that stuff still going on. All right, and what are those things? Well, remember, whatever your trig function is, now it could be any of the 6. The a and the b is what I would take care of first. That's the multiplication stuff. Okay, if it's being done to the x, then it's going to affect the x. And remember, x is one of the opposite of us. So we're going to do the opposite of what's being done. If it's being done not to the x, then therefore it's going to be affecting the y. Remember, y's are y's will do exactly what it says. Multiply by 2, okay, everything's going to be twice as big. Multiply by 1/3, it's going to be 1/3 as big. Then do the shifting either horizontally or vertically. All right, and that means, again, y's versus x's. And because we can have both of these things happening, please, please, please make sure if you are going to tell me what is being done to the x, that you get the x by itself. Okay, you got to make sure that this parenthesis is there, because if it's not, and you have 2x minus pi, you can't tell me what's being done to x, because all you know is what's being done to 2x at that moment. Don't tell me that you're shifting right pi or positive pi, because that's not true. You'd have to cut this in half and cut that in half to factor out that 2 for your b to get the x by itself. Okay, so keep that in mind as you go through it. And don't forget, the a can have multiple things. It can also give you that amplitude, which technically only exists in the first 2, sine and cosine. The others, because they have those asymptotes, there is no amplitude. Okay, the period is always 2 pi, with exception of tangent and cotangent, as we just saw. And remember, if it's being multiplied by some number we're calling b, then we will undo it by dividing whatever our period is by that b. Whatever your period is, divide it by 4 to get your quarters. Okay, so none of that has really changed, which is why we delved very deep into sine and cosine, because they're the easiest. No asymptotes. All the other 4 have asymptotes. And then you just got to practice. All right, and I could ask you any of these types of things on the exam by giving you a question like this and just say, what was the phase shift? What was the amplitude? What was the period? Or even the vertical shift. All right, so work hard at understanding those, not just doing the problems and getting your homework done or the group quiz, and make sure that you write down as much as you can. And as I showed you guys last week with sine and cosine, when there are multiple things going on, I suggest you do them in order. But I also suggest you do them slowly, a little bit at a time, until you get your finished product. Okay, do A here, do B here. And then if C is the last thing, then put it all together in your final graph. Don't try to do all of these things in one full swoop. You'll probably make a mistake. All right, that's it. Good luck, work hard. Remember, all we have left this week is just our review for the exam. So no real reason to meet, but if you guys want to, I'll hold like a little bit longer office hours on Friday for you guys to come in and get some extra help. All right. Have a good one. Hopefully I hear and see from more of you soon. If not, use our TAs. Remember, we have one in person and online. And if you ever get the itch to come to class, you're more than welcome to come to my Tuesday, Thursday class at 8 a.m. at Fresno City. Just reach out. Take care, everyone.